In the words of Richard Feynman, mathematics is not just another language. It is a language plus logic. Mathematics is a tool for reasoning. Now let us know segment formula. AB is a line segment with coordinates A x1 y1 b x2 y2 and P is a point lie on AB which divides AB in the ratio m1 is to m2. m1 is to m2. m1 into some constant m1k m2k. AB is m1k, PB is m2k. That means AB is to PB is equal to m1 is to m2. In this case, if P lies on the line segment joining AB, then we call P divides AB internally. See here, point which divides the line segment joining AB in the ratio m1 is to m2. In the ratio m1 is to m2. Internally, then this internally dividing point P is equal to m1 x2 plus m2 x1 by m1 plus m2. That means A is x1 y1, B is x2 y2 and ratio AB is to PB is m1 is to m2. In this case, internally dividing by P formula, m1 x2 order by m1 x2 plus m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. Because this is a segment formula. P is a point which divides the line segment joining A x1 y1 B x2 y2 internally in the ratio m1 is to m2. Then we can find the internally dividing point formula of P using the formula order by m1 x2 plus m2 x1 by m1 plus m2 comma m1 by 2 plus m2 by 1 by m1 plus m2. We call it is segment formula. If suppose P lies on AB produced, if P lies on AB produced, then we call P divides AB externally. Let us take A coordinates of A as x1 y1 and B as x2 y2 and AB is to PB is m1 is to m2. AB is a sum m1 into L, BP is m2 into some constant L, m1 into constant L, m2 into constant L. Length of AP is m1L, length of BP is m2L, and AP is to BP is m1 is to m2. then we call P divides AB externally. The point which divides joining A x1 y1 B x2 y2 in the ratio m1 is to m2 externally, m1 is to m2 externally is order by m1 x2 minus m2 x1 by m1 minus m2, m1 y2 minus m2 y1 by m1 minus m2, m1 x2 minus m2 x1 by m1 minus m2, m1 y2 minus m2 y1 by m1 minus m2. It is externally dividing point. Internally dividing point formula m1 x2 order where m1 x2 plus m2 x1 by m1 plus m2, m1 by 2 plus m2 y1 by m1 plus m2. Externally dividing point formula m1 x2 order where m1 x2 minus m2 x1 by m1 minus m2, m1 by 2 minus m2 y1 by m1 minus m2. Let us prove these segment formulae. Prove segment formula. Let us prove the segment formula. To prove the segment formula, let us move on to coordinate axis. I am taking horizontal reference line as x-axis, x dash, x is x-axis, and vertical reference line as the y-axis, vertical reference line as the y-axis, y dash y, angle between x dash x and y dash y is 90 degree. Intersecting point of x-axis and y-axis is origin. Now, I am taking a line segment AB with coordinates x1 y1 A x1 y1 B x2 y2 A x1 y1 and B x2 y2, and there is a point P on AB, so that AB is to PB is M1 is to M2, that is AB is M1 into some constant K, PB is M2 K, M2 into K. When we take the ratio AB is to PB is M1 is to M2. Now I am taking a small construction. Draw perpendiculars onto x-axis from A, P, B. First of all, we took let A x1 y1, B x2 y2, and P is a point on AB, so that AP is to PB is M1 is to M2. Let us consider this line segment AB. Now draw perpendiculars from A onto x-axis. AQ perpendicular to x-axis. PR, draw PR perpendicular to x-axis, and draw BS perpendicular to x-axis. Draw AQ perpendicular to x dash OX, and PR perpendicular to x-axis, that means x dash OX, and BS perpendicular to x-axis, x dash OX. After taking these perpendiculars, I am drawing AT perpendicular to PR. Draw AT perpendicular to PR and PU. AT perpendicular to PR, draw AT perpendicular to PR and PU perpendicular to BS. Let us take this construction and draw AT perpendicular to PR and PU perpendicular to BS. Now we have two triangles by these constructions. We can compare these two triangles. Before comparing, let us understand these line segments and those lengths. In fact, perpendicular distance from y-axis to a point is called x coordinate, that is OQ is x1, point x1 y1 mean starting from origin moving x1 units along x-axis, then move vertically y1 units, so that AQ is y1 units. It is very clear. OQ is x1, OQ is equal to x1 units and AQ is y1 units. Now we need to find P. We don't know coordinates of P. I am taking coordinates of P as x comma y. Let coordinates of P as xy. Let P is equal to order pair xy. So that order pair pxy, that to know the point starting from origin, move x units along x-axis, then take a turn, move vertically y units, then we reach the point P. So that OR is x units and PR is y units. OR is x units and PR is y units. On the other hand, point B x2 y2 mean to reach the point B x2 y2, we start from origin O. To locate the point B x2 y2, we start from origin O, move x2 units along x-axis, then move vertically y2 units, then we reach the point B. So that OS, the distance OS is x2 units and BS is y2 units. BS is the y2 units. Let us write OS is x2 units and BS is y2 units. If you observe this figure, OR is x units, OQ is x1 units, so that QR, we can write QR. QR is nothing but OR minus OQ. It is very clear. QR is equal to OR minus OQ. So that QR is equal to OR is x and OQ is x1, x minus x1. So that QR is x minus x1. In fact, AQRT is a rectangle. Why? Because angle Q90, angle R90 and T is 90. In this rectangle, we know opposite sides are parallel and equal. So that QR is equal to AT is equal to x minus x1. Now, AT also, as QR is x minus x1 units, AT also x minus x1 units. QR is, it is very clear. The other hand, QR, therefore QR is equal to AT is equal to x minus x1 units. Now we can find RS also in the same manner. RS, we have OS is x2 units and OR is x units. So that RS is OS minus OR. That is x2 minus x. x2 minus x units. It is very clear. RS is equal to OS minus OR. OS minus OR. OS we have x2 units minus OR x units. Therefore, RS is x2 minus x. In fact, PRSU is a rectangle. As R 90 degree, S 90 degree, and U is 90 degree. PRSU is a rectangle. In rectangle, opposite sides are parallel and equal, so that RS is equal to PU is equal to x2 minus x. So PU also x2 minus x units. RS is equal to, is very clear. Therefore, RS is equal to PU is equal to x2 minus x units. Here we got AT is x minus x1 units, PU is x2 minus x units. As I said, AQRT is a rectangle. AQRT is a rectangle. In a rectangle, opposite sides are parallel and equal. So that AQ is y1 units. So T are also y1 units. T are also y1 units. TR is y1 units. AQ is equal to TR is equal to, we can write AQ is equal to TR is equal to y1 units. Why? Because in a rectangle, opposite sides are parallel and equal. So here we have TR is y1 units and PT is y units. So TR is y1 units, PR is y units, so that we can find PT. PT is equal to PR minus TR. So PT is very clear. PT is equal to PR minus TR. PR minus TR. We have PR is y units, TR is y1 units. That means y minus y1 units. That is equal to PT is equal to y minus y1 units. PT is y minus y1 units. Here as PR y and TR is y1 units, PT is y minus y1 units. And one more, PRSU. PRSU is a rectangle. PRSU is a rectangle. We know in rectangle, opposite sides are parallel and equal. So that PR is equal to US is equal to Y units. We have PR Y units, so US also Y units. PR is equal to US is equal to Y units. PR is equal to Y. PR is equal to US. PR is equal to US is equal to Y units. Now BS is Y2 units and US is Y units. From this we can write BU is equal to Y2 minus Y. BU is equal to BS minus US. BU, you can write BU is equal to BS minus US. That means BS is Y2 minus US is Y units. Y2 minus Y. BU is Y2 minus Y units. That means BU place we can write Y2 minus Y units. Here in this triangle ATP and PUB, we have the sides. AT is x minus x1, PU is x2 minus x, TU is y minus y1 and UB is y2 minus y. AP is m1 into some constant k units, PB is m2 into k units. As we know sides of these two triangles, let us compare these two triangles. Here let us compare triangle ATP and PUB. In triangle ATP, triangle ATP PUB. Triangle PUB. In these two triangles, let us compare the angles. In first triangle, angle P is 90 degree. In the second triangle, angle U is 90 degree. Angle T is equal to angle U is equal to 90 degree. That means one angle is equal. One angle is equal. It is by construction. Since by construction, we constructed AT perpendicular to PR and PU perpendicular to DS. Okay, one angle is equal. On the other hand, it is very clear AT is parallel to PU. AT is parallel to PU. Why? Because we have AQ parallel to PR parallel to DS, and AT and PU, AT perpendicular to PR and PU perpendicular to DS. Lines perpendicular to the parallel lines are parallel, so that we can write AT parallel to PU. We can observe AT parallel to PU, and we can treat BA as transversal. Here AB is the transversal to the parallel lines AT and PU. So that here angle A and angle P, these are the corresponding angles. Angle PAT, angle BPU, these are the corresponding angles. In case of parallel lines, corresponding angles are equal. So that we can write angle PAT is equal to angle PPU. Angle PAT, angle PAT is equal to angle BPU. That means one more angle equal. That means reason is corresponding angles are equal in case of parallel lines. Corresponding angles. Here we have in these two triangles angle P is equal to angle U and angle A is equal to angle P. That means two angles are equal in these two triangles by similarity rule. Since by AA similarity, that means angle similarity, we can say triangle ATP is similar to triangle PU. Triangle ATP similar to triangle PUB. Triangle ATP is similar to triangle PUB. ATP is similar to triangle PUB. We know in similar triangles, corresponding sides are in the same ratio. So that we can write AT by PU. AT by PU is equal to AT by PU is equal to TP by UB. TP by UB. TP by UB, that is equal to AT by PB. AT by PB. Corresponding sides are in the same ratio in case of similar triangles. In fact, AT by PB, AT is x minus x1 units. So that AT by we can write x minus x1 units by P. PU is x2 minus x units. X2 minus x, that is equal to TP. We have TP y minus y1 units. Y minus y1 by UB. We have UB as y2 minus y units. Y2 minus y, that is equal to AP. AP is M1 into K units. PB is M2 into K units. As we are taking the ratio, I am writing as M1 by M2. AP is M1 units. AP as M1, PB as M2. In fact, we need to write it M1 into K, M2 into K. As we are taking the ratio, I am not writing this K. K in K cancels over there. Here we have x x minus x1 by x2 minus x is equal to y minus y1 by y2 minus y, that is equal to m1 by m2. Now we can equate first one and the last one, first one and the third. X minus x1 by x2 minus x, that is equal to m1 by m2. If we take this equation, we can get x coordinate of p, x value we can get by equating the second quantity and third quantity. That means y minus y1 by y2 minus y is equal to m1 by m2, y minus y1 by y2 minus y, that is equal to m1 by m2. By simplifying this, we can get y coordinate of the point P, internally divided point P. Let us simplify these two equations so that we can get the coordinates of internally dividing point P. Here we have x minus x1 by x2 minus x is equal to m1 by m2. To simplify, transpose x2 minus x to the RHS right hand side, m2 to the LHS left hand side. So m2 multiplies m2 into x minus x1 is equal to m1 into x2 minus x. So m2 into x, that is m2x minus distributed law. m2 into x1, m2x1, that is equal to, again distributed law, result of distributed law. m1 into x2 is m1 into x2 minus m1 into x is m1x. Next step, I am transposing the terms having x onto left side. Minus m1x transpose to the left and minus m2x1 to the RHS right hand side. m2x minus m1x become plus m1x, that is equal to, here m1x to the m1x2 transpose minus m2x to the right side, that become plus m2x1. From these two we can common x, so that when we common x, here m2 left plus here m1 will left over, that is equal to m1x2 plus m2x1. Now here x into m2 plus m1 plus m1 is multiplied, so that transpose this to the right hand side. Therefore x is equal to m1x2 plus m2x1 by, as it is multiplying left hand side, divides on the right side, so that m2 plus m1. You can rewrite this as x is equal to m1x2 plus m2x1 by m1 plus m2. We got x coordinate of the internally dividing point P, as we took P with coordinates xy. That first coordinate x we got, x is equal to m1x2 plus m2x1 by m1 plus m2. Now let us find y value, y coordinate value using the second equation. We have y minus y1 by y2 minus y is equal to m1 by m2. Just do cross multiplication. That means transpose m2 to the left hand side, y2 minus y to the right hand side. Here y minus y1, m2 into y minus y1, that is equal to m1 into y2 minus y. Now we have, using distributive law, m2 into y is m2y minus m2 into y1, m2y1, that is equal to m1 into y2, m1y2 minus m1 into y, m1y, transpose terms having y onto one left hand side and remaining terms to the right hand side. Here m2y transpose minus m1y to the left hand side, that becomes plus m1y, that is equal to here m1y2 minus m2y1 transpose to RHS, that becomes plus m2y1. From these two terms we can common y, so that y into m2 plus m1 is equal to m1y2 plus m2y1. Here m2 plus m1 is multiplying, transpose it to RHS, so that y is equal to m1y2 plus m2y1 by here m2 plus m1 multiplying y. If we transpose the two right hand side, that divides, so divided by m2 plus m1. We can rewrite it as y is equal to we can write it as m1y2 plus m2y1 by m1 plus m2. We got x coordinate of p, x is equal to m1 x2 plus m2 x1 by m1 plus m2. Y coordinate of internal dividing point p, y is equal to m1 y2 plus m2 y1 by m1 plus m2. So we got the x coordinate and y coordinate, first coordinate and second coordinate of internally dividing point p, which dividing line segment joining ax1 y1 bx2 y2 in the ratio m1 is to m2. There is in fact we took p as internal dividing point p as x comma y. Therefore p internal dividing point p is x. We have m1 x2 plus m2 x1 by m1 plus m2, m1 x2 plus m2 x1 by m1 plus m2, comma second coordinate m1 y2 plus m2 y1 by m1 plus m2. There is m1 y2 plus m2 y1 by m1 plus m2. We call it as segment formula, internally dividing by formula. Like the point which divides the line segment joining ax1 y1 bx2 y2 in the ratio m1 is to m3 is ordered where m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. Find the point which divides the given line segment externally in the ratio m1 is to m2. Find the point which divides the line segment joining A x1 y1 b x2 y2 in the ratio m1 is to m2 external. So we are going to find formula for externally dividing point in the ratio m1 is to m2. For this I am moving on to coordinate axis. I am taking a horizontal reference line x axis and a vertical reference line. Y-axis, and I take a line segment on this coordinate plane as ax1 y1 and bx2 y2. I am taking a line segment which is ax1 y1 and bx2 y2. There is the AB, ax1 y1 and bx2 y2, and there is a point P which is on AB produced. PB on P is on AB produced. The point, if P is on AB produced, then we say P divides AB externally, and given A x1 y1, B x2 y2, and there is a point P on AB. P on AB produced, so that P on AB produced, so that AP is to BP is M1 is to M2. That means AP is M1 into some constant L. BP is M2 into some constant L. I am writing as M2. Why? Because in case of ratio, that the constant get cancelled. In fact, M1 into L, M2 into L for some constant L. L is other than 0. Whole number other than 0. Here M1L, M2L. AP is to PB, AP is to BP is equal to M1 is to M2. That means P dividing AB externally. P dividing AB externally. Now we are going to find this externally dividing point P. Let us take the point P as x, y. Let us take P as order pair x, y. Let P is equal to x, y. Let us do a small construction in this coordinate plane. In this coordinate plane, from A, B, P, I am drawing perpendiculars onto x-axis. Draw AQ perpendicular to x-axis and BR perpendicular to x-axis and PS that is also perpendicular to x-axis. We draw AQ, BR and PS. Draw AQ, BR and PS perpendicular to x-axis, x dash ox, that means x-axis. We can understand the point ax1, y1 as OQ moving x units along, x1 units along x-axis, then move vertically y1 units. We can understand the point bx2, y2 as starting from origin, move along x-axis as OR is x2 units, then turn vertically and move y2 units. That is RB is y2 units. Then we can understand point PXY as OS. OS is x units, move along x axis x units, then turn vertically, move along y units, move y units. Then draw AT perpendicular to BR, draw AT perpendicular to BR and BU, draw BU perpendicular to PS, BU perpendicular to PS. From this construction, two triangles are formed. One is A triangle ADB and the other triangle BUP. We can compare these two triangles to get the required result. Before that, we need to come to know the lengths of the sides of these triangles. As OR is x2 units and OQ is x1 units, it is very clear QR is x2 minus x1. We can write QR is x2 minus x1 units. As AQRT is a rectangle. As AQRT is a rectangle. Opposite sides are parallel and equal, so that QR is equal to AT is equal to x2 minus x1. AT also x2 minus x1 units. QR is equal to AT is equal to x2 minus x1 units. And one more. Here we have OS is x units and OR is x2 units. So that RS is equal to OS minus OR. There is x minus x2 units. So RS is x minus x2 units. As BRSU, a rectangle, BRUS is a rectangle, so that in rectangle opposite sides are parallel and equal, so that RS is equal to BU is equal to x minus x2. BU also x minus x2. RS is equal to BU is equal to x minus x2 units. On the other hand, BT we need to know the BT length. Before that, as AQRT is a rectangle, AQ is equal to TR is equal to Y1 units. TR is a Y1 units. That is Y1 units. AT is equal to AQ is equal to TR is equal to AQ is equal to TR is equal to Y1 units, as opposite sides are equal in a parallel and equal in a rectangle. In BR is opposite sides are parallel and equal. Here BR is equal to US is equal to Y2 units. It is Y2 units. It is Y2 units. BR is equal to US is equal to Y2 units. So that here we have BR is Y2 units and TR is Y1 units. So BT is equal to BR minus TR. BT. Therefore BT is equal to BR minus TR. So that BR is Y2, TR is Y1. That is Y2 minus Y1 units. BT is equal to Y2 minus Y1 units. BT is Y2 minus Y1 units. In the same manner, PU length we can come to know. PU is equal to PS minus US. PU is equal to PS minus US. Therefore, PU is equal to PS. PS length is Y units and US length is Y2 units. So Y minus Y2 units. So PU length is Y minus Y2 units. Y minus Y2. Now, in triangle ATB and BUP, we have the lengths of the sides. AT length is x2 minus x1 units. BU length is x minus x2 units. BT length is y2 minus y1 units. And PU length is y minus y2 units. On the other hand, as AP is m1 into L and BP is m2 into L, we can write AB is equal to AP minus BP. AP minus BP. Therefore, AB is equal to AP minus BP. AP length is m1 into constant L minus BP is m2 into constant L. There is therefore AB is equal to, we can common L, so that m1 minus m2 into L units. So we have AB length m1 minus m2 into L units. Here in ADP, we came to know lengths of the three sides as x2 minus x1, y2 minus y1, m1 minus m2 into L. In BUP, lengths of the sides x minus x2 units, y minus y2 units, and m2 into L units. So that now we can compare these two triangles ATB and BUP. Let us compare these two triangles. Now let us compare these two triangles ATB and BUP. In triangle ATB, in triangle ATB, comma BUP and BUP. It is very clear. Angle P is 90 degree and angle U is 90 degree by construction. Angle P is equal to angle U, that is equal to 90 degree. That means when angle is equal, since by construction. And one more. Here it is very clear. AT is parallel to B. As AT is perpendicular to BR and BU is perpendicular to PS and BR parallel to PS. BR parallel to PS. Lines perpendicular to the parallel lines are parallel. So that AT parallel to BU and then we can treat AP as transversal to the parallel lines AT and BU. So that here angle A and angle B are the corresponding angles. In case of parallel lines, we know corresponding angles are equal. So that angle BAT is equal to angle PBU. Angle BAT is equal to angle PBU. Reason, corresponding angles are equal in case of parallels. Corresponding angles. That means one more angle is equal in these two triangles. In these two triangles, angle P is equal to angle U and angle A is equal to angle B. So two corresponding angles are equal. Since by angle similarity, we can say triangle ATB is similar to triangle BUP. Triangle ATB is similar to triangle BUP. We know in similar triangles, corresponding sides are in the same ratio. So that AT by BU is equal to here AT by BU is equal to TB by UP. TB by UP. That means TB by UP in these two triangles. That is equal to AB by BP. AB by BP. That is AB by BP. AB by BP. Again, AT by BU is equal to TB by UP is equal to AB by BP. Here we have AT as x2 minus x1. AT place we can write x2 minus x1 by. We have BU. BU as x minus x2 by x minus x2. That is equal to TB. We have TB as y2 minus y1, that is y2 minus y1 by UP. We have UP as y minus y2 units, y minus y2 units by y minus y2 units, that is is equal to AB. AB length is AB length is m1 minus m2 into L. m1 minus m2 into L by BP. We have BP as m2 into L. m2 into L. L in L get cancelled one time. So if we solve, if we get these, if we solve these equations for x and y, we get externally dividing point coordinates. So from this we have x2 minus x1 by x minus x2, x2 minus x1 by x minus x2. Let us equate the first one and the third one, that is equal to m1 minus m2 by m2. On the other hand, we can equate second one and third one, that is y2 minus y1 by y minus y2. Y minus y2 is equal to m1 minus m2 by m2. x2 minus x1 by x minus x2 is equal to m1 minus m2 by m2, and y2 minus y1 by y minus y2 is equal to m1 minus m2 by m2. If we simplify the first equation, we get the x coordinate, and by simplifying the second equation, we get y coordinate of the externally dividing point. Let us simplify for x and y. Here transpose m2 to the left and x minus x2 to the right side. That means just do cross multiplication. m2 into x2 minus x1, that is equal to m1 minus m2 into x minus x2. m1 minus m2 into x minus x2. Let us simplify. Here m2 into x2 is m2x2, m2x2, plus into minus minus, distributive law. Let us apply distributive. m2 into x1, that is equal to m1 into x, m1x. Next, m1 into x2, m1x2, plus into minus minus, m1x2. Minus m1 m2 into x minus m2x, and minus m2 into minus x2, minus into minus plus m2x2. Here we have m1 m2x2 minus m2x1 is equal to m1x minus m1x2 minus m2x plus m2x2. I am transposing the terms which have x onto left hand side and the remaining to the right hand side. Here x terms are the x having terms are in RHS, so the remaining terms I am transposing to left hand side. m2x2 minus m2x1 minus m1x2 transpose to left side, so plus 1 m1x2 plus m2x2 transpose to left hand side minus m2x2, that is equal to m1x minus m2x, m1x minus m2x. Here plus m2x2 minus m2x2 get cancelled. From these two we can write as m1x2. We can rearrange as m2x2 minus m2x1. On the right hand side, common x, so that x into m1 minus m2 into m1 minus m2 transpose to left hand side. As it is multiplying in RHS, it divides the LHS. m1x2 minus m2x1 by m1 minus m2 is equal to x. We got x coordinate of the externally dividing point. X is nothing but x coordinate of the externally dividing point p in the ratio m1 is to m2. That is m1x2 minus m2 x1 by m1 minus m2. Now let us simplify the second equation for y. Just do cross multiplication, m2 into y2 minus y1, that is equal to m1 minus m2 into y minus y2, m1 minus m2 into y minus y2. Next, m2 into y2, m2 y2 plus into minus minus m2 into y1, m2 y1, that is equal to m1 into y, m1 y plus into minus minus m1 into y2, m1 y2 minus m1 y2 minus into plus minus m2 into y1 y, m2 y minus into minus plus m2 into y2, m2 y2, m2 y2. Now the terms having y I am leaving in RHS and the remaining terms transposing to left hand side, minus m1 y2 and plus m2 y2 transpose to LHS, m2 y2 minus m2 y1 minus m1 y2 become plus m1 y2 minus m2 y2 in RHS in left hand side, that become minus m2 y2, that is equal to m1 y minus m2 y. Here plus m2 y2 minus m2 y2 get cancelled. From these two we can write these two terms as m1 y2 minus m2 y1, that is equal to, from these two we can common y, so that when we common y, m1 minus m2, there within bracket, m1 y2 minus m2 y1 is equal to m1 minus m2 into y. Transpose into m1 minus m2 to left hand side, that divides. So m1 y2 minus m2 y1 by m1 minus m2 is equal to y. We got the y value, that is nothing but y coordinate of p externally dividing by p, that is m1 y2, y is equal to m1 y2 minus m2 y1 by m1 minus m2. Therefore externally dividing point, we took externally dividing point p, externally dividing point of line segment join a x1 y1 b x2 y2 in the ratio m1 is to m2 is, that is nothing but txy, that is m1 x2 ordered by m1 x2 minus m2 x1 by m1 minus m2, comma m1 y2 minus m2 y1 by m1 minus m2. This is externally dividing point pxy, which divides the line segment joining AB in the ratio m1 is to m2 externally.